Welcome students. In this class we will be dedicating the session for doing questions related to order and degree of a differential equation. Now this is one particular topic which predominantly occurs in all forms of examinations, be it the high school level examination, graduate school examination, or even if you want to get into a research project. This particular topic keeps occurring on and on. Now, having mentioned about this particular topic, without any further delay, let me just recap what exactly the order of a differential equation. So the order, it is the highest differential that is present in a differential equation, right? So this is the first important point that you will have to know with regard to order. Now coming to degree, what exactly is degree? Now it is the highest power of the highest differential when after converting the differential equation into polynomial form. So have that in mind. So what do you mean by polynomial form? We will have to remove the fractional powers. Okay, so we have got two important definitions which we will be using to answer and to solve questions related to order and degree. Okay students, we've been given this question. We expected to find the order and the degree. Now just go and review the definition given for order. It is the highest differential that is present in a differential equation. Now what is the highest differential that you can see here? This is dy over dx, but this is d squared y over dx squared. So naturally, without any element of doubt, you can clearly state that the order is 2. But when it comes to degree, you will have to be a little bit cautious, because according to the definition, it is the highest power of the highest differential after converting the differential equation into polynomial form. So that means we will have to get rid of these fractional powers. So how are we going to do that? Now this has got a fractional power of 1 over 5. So what I will be doing, taking fifth power both sides. So this is going to be d squared y over dx squared. Now I'm taking fifth power both sides, and on the right hand side is going to be 2y positive dy over dx raised to the power of 6. This is 1 over 5. This entire thing has to be raised to the power of 5. So what happens when you do that? Clearly you can see the 5 and the 5 will be cancelled, and that would leave me on the right hand side 2y positive dy over dx raised to the power of 6, and on the left hand side it is d squared y over dx squared raised to the power of 5. So what does the degree state? It is the highest power of the highest differential. You can clearly see the highest power of the highest differential. This is the highest differential. So what's the degree? So the degree is 5. So that is the solution for this question, students. Students, let's do the next question. We've been given dy over dx positive 3 times y is equal to 1 over dy over dx. Now clearly you can outrightly state that the order is 1, but when it comes to degree, as I mentioned to you, you'll have to be a bit careful. Now this is not in polynomial form. To bring it in polynomial form, I would be multiplying both sides by dy over dx. So when I do that, I would get dy over dx raised to the power of 2 positive 3 times y times dy over dx, and when I multiply by dy over dx, this is going to be equal to 1. And of course I can bring this 1 to the left hand side, but it doesn't not matter because this is already in the form that we wanted. Now clearly you can see this is the highest differential, and what is the power here? 2. So that would be the solution for this question. Students, we are given this question: negative e raised to the power of d squared y over dx squared positive 2 times x dy over dx positive y is equal to 0. Now the highest differential in this case would give me the order. So my order is equal to 2. Now, but when it comes to the degree, we will have to represent this in polynomial form. So foremost, what I wish to do is I would like to move this to the other side. So that means I would now have e raised to the power of d squared y over dx squared is equal to 2 times x dy over dx positive y. Now taking ln both sides, let me write that down. Taking ln both sides, we get, so what do we get? This is going to be ln of e raised to the power of d squared y over dx squared is equal to ln of 2 times x dy over dx positive y. Now we know that ln of a raised to the power of b is nothing but b times ln a, and we also know that ln e is, suppose the base is actually e here, right? So ln e to the base e will give us 1, and we also know that suppose you have something like this, ln e raised to the power of say some a, I can rewrite this as a times ln e, which is nothing but equal to a, right? So these are all some of the snippets that we will have to know. So first, what I wish to do is I would like to bring this down, okay, bring the quantity to the forefront using this law. Ln e raised to the power of a can be written as a times ln e. So I'm going to do that. So that's going to be d squared y over dx squared times ln e is equal to ln of 2 times x dy over dx positive y. Now ln e to the base e is equal to 1, right? So that would mean I get d squared y over dx squared is equal to ln of 2x times dy over dx positive y. So this is what we've got. Now the question comes, is this polynomial form? Yes or no? The answer is a simple no. Because when we talk about polynomial form, we do not have a presence of the logarithmic function involved. So what should be the answer in this case? So in this case, the degree is undefined. You can say not applicable, or you can use the word undefined. So depending on what choice that they are giving you. The problem in this case is that the derivative dy over dx is fused inside the logarithmic function. So that is the major issue. So because of that issue, that the derivative being stuck inside the logarithmic function, I am unable to represent this entire equation in polynomial form. Okay? So because of that, we have the degree to be undefined, or you can say not defined. We can use any of these things. So we'll move on to the next question. So we're given this question, we expected to find the order and degree. So we got tan inverse of dy over dx is equal to x positive 2y. And first and foremost thing that we need to do is we need to make sure that this equation is in polynomial form. So I'm going to rewrite this as dy over dx by moving the tan inverse to the other side. So that would mean I now have tan of x positive 2y. Now the first observation you will have to make or do here is to check for dy over dx, or for that matter any order of dy over dx, to see if it is fused in between any functions or so. Now clearly you can see here that there isn't any dy over dx present here, unlike the previous case. Now if you were to look at the previous case, you can see that dy over dx is actually inside another function. So that means we are unable to obtain the polynomial equivalence for this. And that is the reason we have arrived at a situation that the degree is undefined. But in this case, if you were to observe the question, clearly you can see that dy over dx is standing alone, and there isn't any dy over dx sandwiched between a third function. So that would mean I got the form that I'm looking for. So clearly you know that the order, the highest differential is 1, and the degree of the highest differential is also 1. So that is the end of the solution for this question. Students, we are given this question: ln of d squared y over dx squared is equal to a times x positive b times y. We are expected to find the order and the degree. So foremost, we will have to rewrite this in polynomial form. Now you might be wondering, oh, the differential quantity d squared y over dx squared is present inside a logarithmic function, and we clearly have seen a question where d squared y over dx squared was fused inside a logarithmic function, and we immediately concluded that the degree of the equation was undefined or not defined. So I can say, use the same precedence that I have experienced to conclude that in this case also the degree is undefined. Well, before you could make that decision, you will have to ensure that you are firmly correct on your decision. So for that, the only criteria, or in other words, the yardstick that would help you to make sure that your decision is correct, is to convert this given equation into the polynomial form. So first make that attempt. Now clearly I know that if I've got something like this, say ln a to the base e, if it is equal to y, by logarithmic laws I can write this as a is equal to e raised to the power of y. Now using this law, I'm going to write this quantity as d squared y over dx squared is equal to e raised to the power of a times x positive b times y. Now the first thing that you will have to see here is, observe that if the differential operator, or for that matter d squared y over dx squared, or any order of differential, is sandwiched or it's caught between a third function or another function. Now clearly you can see that there is nothing that stops d squared y over dx squared being encircled by a third party function or by another function. Clearly I can see on the left side I only got d squared y over dx squared, and on the right hand side it's a quantity which comprises of terms without the presence of dy over dx or any differential operator. So that means we have obtained the form that we are looking for. So clearly we can find the order from here. The order in this case is the highest differential, so that's going to be 2. And in this case the degree is going to be the power of the highest differential, and that's going to be equal to 1. Simple as that. So that completes the solution to this question. Students, we will move on to the next one. Students, we are given this question, we are expected to find the order and degree. We are given one positive 3 times dy over dx raised to the power of 2 over 3 is equal to 5 times d cubed y over dx cubed. Now there is a fractional component here, so we will have to get rid of this and write this in polynomial form. So what I'm going to do is I'm going to be erasing both sides to third power. So if I were to do that, this is going to be 1 positive 3 times dy over dx raised to the power of 2 over 3. This is raised to the power of 3, which is equal to 5 times d cubed y over dx cubed. This is raised to the power of 3. Now clearly you can see that this 3 and the 3 here can be cancelled, giving me 1 positive 3 times dy over dx, and that has to be raised to the power of 2. In this case I get 5 cubed and d cubed y over dx cubed, and this is raised to the power of 3, right? So clearly you can see the order. This is 3, and the degree is nothing but the power of the highest differential, so that's also 3. So this is the solution to the question. Students, we are given this question. We are expected to find the order and the degree. Now the question is dy over dx is equal to 2 positive square root of dy over dx. Now you can clearly see that the differential operator dy over dx is actually caught within another operating function. So our main aim is to first disentangle the operator dy over dx. In other words, I would like to remove this dy over dx from the clutches. So our objective is to remove this operator from the hold of the square root operation. So let's do that. So foremost, what I would do is I would like to bring this 2 to the left side. So if I were to do that, I would get dy over dx negative 2. On the right hand side it's going to be dy over dx. So to get rid of the square root, I would have to square both sides. So if I were to square both sides, this is going to be raised to the power of 2. This is going to be raised to the power of 2. Now clearly you can see that the radical sign and the square, they get cancelled, leaving me with dy over dx. On the left hand side, this is a minus b raised to the power of 2, which is going to be a squared negative 2 times ab positive b squared. So if I were to use this expansion, this is going to be dy over dx raised to the power of 2 negative 2 times, and there is a 2 there, that means there's going to be 2 squared times dy over dx, and followed by 2 squared. So this is what I've got. Now clearly you can see that the highest derivative is of order 1, and the degree of the highest derivative here is 2. So this should be the solution. So you've got to be a little bit careful in handling this question. Now if in case they give another variation, say for example they have this like this, say d squared y over dx squared is equal to, say, negative 1 positive square root of dy over dx. Now as I mentioned to you, we will have to make sure that the required differential equation is in polynomial form. So I would have to move this negative 1 to the left hand side. So that would mean I now have d squared y over dx squared positive 1 is equal to square root of dy over dx. Now squaring both sides, what do we get when we square both sides? I would write it here. So this is going to give me d squared y over dx squared positive 1 raised to the power of 2 is equal to root of dy over dx raised to the power of 2. So clearly you can see that the radical sign and the 2 gets cancelled, leaving me with dy over dx on the right hand side. On the left hand side, this is going to be d squared y over dx squared raised to the power of 2 positive 2 times d squared y over dx squared, positive 1. Now we are looking for the highest order differential. So clearly the order in this case is going to be 2, and the degree is nothing but the power of the highest derivative. So in this case the power is 2, so the degree is going to be 2. So prepare yourself, and most of the times when it comes to order and degree, these will be the problems that would predominantly be posed to you. So with this extrapolated exposure, I am sure with some amount of practice you will be able to click the things when it comes to order and degree. So we will move on to other related questions on order and degree, making sure that you are able to get a hit on. Students, we are expected to find the order and the degree for this particular question. We are given 6 times y double dash is equal to 7 positive y dash raised to the power of 2. The entire quantity is raised to the power of 5 over 2. Now we are not given terms like d squared y over dx squared, but instead of that we are given y double dash. Now this can also be confusing. Now foremost, what you have to do is you have to convert this into polynomial form. Now what prevents us from converting this into polynomial form is the presence of this fractional power. So I will have to get rid of the fractional power. How could I do that? By squaring both sides. That is the remedy. So if I were to square both sides, this is going to be 6y double dash raised to the power of 2 is equal to 7 positive y dash raised to the power of 2. Now this is 5 over 2. This entire thing is squared. So when it is squared, naturally the 2 and the 2 gets cancelled. Why does it get cancelled? Suppose you got a quantity like a raised to the power of m over n, and you are taking it to the power of n. Then by the law of indices, this can be rewritten as a raised to the power of m over n times n, which means I can still further rewrite this by cancelling the n as a raised to the power of n. So that's from the law of indices. So having obtained the output, we need to formulate this. So this is going to give me 6 squared times y double dash raised to the power of 2 is equal to 7 positive y dash raised to the power of 2, that is raised to the power of 5. Now this has got no significance to the order or to the degree in this particular question, because we are always concerned with the highest differential. So if I were to look into the highest differential, clearly the order of this differential is 2. So we can just place the value there. So let me just go and place the value 2 there. And what is the power in which it is raised? That gives the value for the degree. So that solution is going to be 2. So that completes the solution for this question, students. We will move on to the next question. Students, we are given this question: d cubed y over dx cubed, this is raised to the power of 2 over 3, is equal to dy over dx positive 5, and we are expected to find the order and the degree. Now foremost, the best thing to do is to get rid of this fractional power and then write it in polynomial form. So for that I need to remove this 3. So I would be cubing both sides. We get, so this is going to be d cubed y over dx cubed. This is raised to the power of 2 over 3. Now I'm cubing this term, so I get a 3 there. This is going to be equal to dy over dx positive 5. It's raised to the power of 3. Now clearly from the law of indices I can cancel the 3 that you see here, and that would mean I would now have d cubed y over dx cubed raised to the power of 2 is equal to dy over dx positive 5 raised to the power of 3. Now from here clearly I can see that the order is 3. I can write that, and then the degree is nothing but the power that the highest differential has. So in this case the power is 2. So that completes the solution for this question. So we'll move on to the next question, students. Students, we are given this question: y equal to 1 positive dy over dx positive 1 over 2 factorial times dy over dx raised to the power of 2 positive 1 over 3 factorial times dy over dx raised to the power of 3 positive etc. up unto infinity. So this is actually an infinite series. Now this has got a lot of correspondence with our e raised to the power of x series, which is nothing but 1 positive x over 1 factorial positive x squared over 2 factorial positive x raised to the power of 3 over 3 factorial plus up unto etc. It goes up to infinity. So this is a very important series, and we will try to use this series to solve this question. So if I were to take x to be as dy over dx, then I can clearly see that all I need to do is to substitute in place of x dy over dx, and I would get this entire series dy over dx positive 1 over 2 factorial times the dy over dx raised to the power of 2 plus etc. So clearly we can see that I can write y to be as e raised to the power of dy over dx, but this is not in polynomial form because of the presence of this exponential. To get rid of the exponential, we will take natural log on both sides. So this is going to be ln y is equal to ln e raised to the power of dy over dx. This is going to be dy over dx, and on the left hand side is going to be ln y. So clearly we see the differential operator is not within or inside any function. So this is acceptable. So this is the only differential that we have got. So therefore we can state that order is equal to 1 and the degree is equal to 1. So this completes the solution to this question, students. Students, we are given this question. We expected to find the order and the degree. Now this question can be very tricky. Now because we got the degree, or I should say we got the entire component b raised to the power of 5, and on the left hand side we got x cubed times d squared y over dx squared. Now if you were to observe this, this is exactly in the polynomial form, and also it is imperative to observe that the differential operator is not inside any other third function. So this is a straightforward question. All you need to do is to find the highest differential. In this case is d squared y over dx squared. So the order is going to be 2 here. And then followed by that, find the power to which the highest differential is raised. So in this case it is raised to power 1. So that would be my degree. That's it. This is the end of story for this question. So we got this question. We expected to find the order and the degree. The question is d squared y over dx squared positive x squared times dy over dx raised to the power of 2 is equal to 3 times x cubed times log of d squared y over dx squared. Now if you were to make an observation here, your focus should fall on this right hand side, because you can see that d squared y over dx squared is entangled within logarithmic function. So that would mean if you were to, or if you want to find the degree, you should remove this logarithm. In other words, you have to remove the differential operator d squared y over dx squared from the logarithmic function in which it is present. So how are you going to do that? Because the logarithmic function is directly covering the differential operator d squared y over dx squared. So in that case, at the most what you can do is you can move this 3 times x cubed down as a denominator. That's it. If you want to remove this logarithm, even if you were to manipulate the left hand side, the logarithm will still come haunting back either to the left side, or it would manifoldly augment its tentacles, because of the fact that the logarithmic function is holding on to the differential operator d squared y over dx squared. So in other words, what I'm trying to convey here is it's just not going to be possible for you to get the polynomial form. and that would mean our degree is not going to be present there. So for that, let me start off with the order. Clearly the highest differential present here is 2, so I can write that 2. In case of the degree, as I mentioned to you, the only feasible solution is going to be not defined. So that's it. So this is going to be our solution for this question.